Okay, so let's look at an example of how we might do this. This is number 57 in your book. And it asks, it gives you a diagram, a PV diagram that has a isothermal change from A to B. So this, again, this is our PV diagram. It has an adiabatic change from B to C. And then it has a return to A through that process right there. So this is isothermal. This is adiabatic. And this is some combination. And it tells us that the work done from A to B, we measure that to be 700 joules. And we're expanding. And then it asks us, what is the amount of heat? Well, since we're on an isotherm, the change in internal energy is 0, right? There's no change in temperature, so the change in internal energy is 0. And therefore, the if this is equal to Q minus W, the work from A to B is equal to the heat from A to B. So that has to be 700 joules. Then we expand adiabatically from B to C, and it says that the work done there from B to C is equal to 400 joules. Now, because it's adiabatic, we know that the heat has to be 0. So there's no heat exchange, which means that my change in internal energy is negative 400 joules because I have Q minus WBC. And since WBC is a positive, we have a negative 400 joules right there. And then it asks us, if we go back from A to C, and we lose heat from A to C of 400 joules, or 100 joules, then what is the work done on this process right here, going back to A? So, finally, we look at this and we say, okay, well, we've got, I'm returning back to my original change in energy. So the change in energy, that's going to be at a hotter temperature, so that's going to be 400. So my change in internal energy from C to A is equal to 400. But that's also equal to the heat, which we have 100 joules coming out. And we're trying to figure out how much work is done from C to A. So this is going to be, and this heat is negative because it's leaving the system, so that's going to be 500. That's equal to minus WC, and so the work is going to be negative 500 joules, and that's negative because it's work done on the gas as it's compressed.